our solar system, and we've been tracking its progress very closely, especially because Professor Loeb suspects that it might actually be alien technology scoping us out. And for those who like a side order of conspiracy theory with their servings of UFOs, he claims, Avi Loeb does, that NASA is keeping critical evidence about 3I-ATLAS away from public view.
The huge amount of heat from the sun, and the latest report indicates that it became extremely bright, much more than expected for familiar comets.
What does that tell you?
Well, that is not the most unusual fact. It actually is bluer than the sun. And a blue color usually indicates very high temperatures if the light is emitted by some hot surface.
But that was only the beginning. The object at the center of this investigation is cataloged as 3I-ATLAS, an interstellar visitor that did not form here, yet now crosses our system with a stubborn refusal to behave the way our textbooks say it should. From the first weeks of monitoring, there were hints that the ordinary playbook would not fit. Then in late October, the story sharpened. The sun itself surged into one of its most powerful activity spikes in decades. Almost in lockstep, 3I-ATLAS brightened far beyond what the familiar comet laws predict. It did not merely glow, it shifted in a way that forced careful observers to ask questions they were not planning to ask. Start with the physics everyone was ready to accept. As the object closed in on perihelion, its closest approach to the sun, solar irradiance rose sharply. At roughly 136 astronomical units, the heat load was severe by any reasonable baseline. When ordinary comets enter that regime, their ices sublimate, their comas swell, their tails grow, and their brightness climbs along a curve the community understands. 3I-ATLAS followed that script at first glance. Then the details refused to cooperate. The brightening rose too fast. The color skewed bluer than expected. And the timing aligned a little too cleanly with bursts of solar storms that were powerful enough to distort magnetic fields across the inner system. In parallel, another thread emerged from a different quarter of the evidence. Across multiple reduction pipelines and independent analysis teams, a small, repeatable, non-gravitational acceleration kept showing up in the astrometry. Think of the perfect path that gravity alone would draw across the sky. Now imagine the real object drifting a hair's width to one side of that line. Too small for drama, too coherent for chance. Analysts did what they are supposed to do. They tuned calibrations, swapped assumptions about radiation pressure and thermal recoil, inserted canonical outgassing terms, and resolved the orbit from scratch. Each solver shaved the residuals a different way. None erased them. The best fits kept requiring a directed push. On their own, either story could be dismissed as a curiosity. Together, they created a profile. When the sun roared, 3I-ATLAS brightened hard and blue. When the data were filtered and refit, the trajectory still carried a small extra term that gravity could not own. Months earlier, a milder version of the same choreography had played out near the approach to Mars. A measured climb in luminosity followed by a clean decay back to baseline once that window had passed. Twice is not coincidence. It is protocol. The easy explanation, and the first one responsibly considered, was just outgassing but smarter. Suppose the volatiles are buried under a crust, venting through tiny nozzles that line up with the spin. The thrust is efficient, the coma is subdued, and the momentum bookkeeping works without invoking anything exotic. That hypothesis can be tested. If it is right, then the post-perihelion mass loss estimates, dust-to-gas ratios, and the changing shape of the light curve should match thermophysical models that conserve energy and momentum realistically. If those numbers refuse to reconcile, the hypothesis bends until it breaks. The second conservative frame is sunlight itself. Radiation pressure on a thin, high area-to-mass surface will accelerate more than a lump of rock. If 3I-ATLAS is unusually thin or sail-like, the sun can push it without propellant. That math also works, but a sail inherits the rest of the ledger. The odd polarization, the composition hints, the rotation stability where heat should have nudged the period, and the layered sheath that does not look like a simple mix of icy dust. Composition was supposed to be the easy out. Split the light. Read the lines. Let the chemistry confess. Instead, the spectra kept hinting at a coma where carbon dioxide dominated, and the expected water signature underperformed at the levels you would need to power the observed behavior. In places, the inner envelope looked nickel-heavy with iron underrepresented, flipping the abundance expectations seen in most settings we have cataloged. Farther out, cyanide-bearing compounds showed up, with carbon dioxide stronger still in the outer layer. None of this forces a sensational conclusion. All of it forces better models. Then came the geometry and the cadence, the two things always ignored by speculation and always decisive in real work. Western observatories cycled through maintenance, instrument swaps, and scheduling gaps during a critical window. The best-placed eyes were not in the places that normally set the tone of the narrative. High-altitude facilities in Asia kept their nightly vigil, optimized for long-duration monitoring rather than single glamorous frames, and their continuous record bridged the gap. As the solar storms rolled through, the object's coma elongated in a direction consistent with particle stream interaction. The brightness rose by an amount too large to shrug off as noise, then settled back when the forcing eased. The trajectory, meanwhile, remained exactly where the equations said it should be. The object was not steering. The light was reacting. At first, that might sound like a trivial distinction. In reality, it draws a bright line through the interpretation. If the path matches gravity but the light misbehaves, the system exchanging energy with the sun is not the bulk mass. It is the surface and the sheath, the dust, gas, and plasma that surround the body. That points toward physics we already know in other settings: auroras brightening when charged particles strike a magnetosphere, plasma flows coupling to fields and accelerating, grains charging, discharging, and radiating under electrical stress. Conservative Comet models say heat drives gas, gas drives dust, dust reflects sunlight. Electrical models say currents and fields can do real work in the coma. 3IATLAS sits in the gap between those frameworks. It carries the signature of cold formation. It acts like it keeps volatiles under pressure, and yet it's timing against solar storms and its color shift demand that plasma coupling and non-thermal processes share the stage. Against that backdrop, the older anomalies did not go away. Polarimetric measurements showed strong negative polarization, where comets reliably show the opposite sign. That is not a headline. It is a lab-testable optical property, and 3IATLAS landed on the wrong side of it. Mid-year, an anti-tail episode sent material sunward before flipping back to a canonical tail near perihelion. Rotational light curves, faint but measurable, suggested a stabilized spin state rather than a free tumble. Ordinary heating tends to torque small bodies and drift their periods. Here, within uncertainties, the period held steady. Again, not a verdict, just a consistent sketch. There is a temptation when confronted by such a sketch to jump to the last page of the story. Resist it. Real investigations do not trade caution for drama. They trade patience for clarity. That is why the next steps have been spelled out in plain terms. Track the separation between the real object and a gravity-only ephemeris at milliarc-second precision. If a directed non-gravitational term is truly present, the separation should grow faster than the shrinking uncertainty envelope as the weeks go by. If the separation collapses into the error bars with better data, the anomaly dissolves. In parallel, measure the post-perihelion rotation period to millisecond precision. If the period refuses to budge when thermal torques should have nudged it, stability becomes another weight on one side of the scale. At the same time, look for thermal infrared excess that would tie push to power, and sit radio facilities near the protected 1420 MHz hydrogen line, not expecting a greeting, but prepared to catch the narrowband leakage that unintentional technology often leaves behind. All of this has been happening while the sun rolls toward a vigorous maximum, with sprawling sunspot groups that have already driven storms strong enough to paint auroras in places unaccustomed to them. This is where the story becomes less abstract and more immediate. We have built a civilization that assumes the sun will behave. Satellites quietly synchronize time for banking and markets, steer aircraft on polar routes, guide container ships across lanes invisible to the eye, and stabilize the timing of communications that most people never think about. A sufficiently strong coronal mass ejection can heat and expand the upper atmosphere, increase drag, alter orbits, and cascade small errors into big failures. We have seen satellites lost during geomagnetic surges in our own near past. Power grids that were never designed for geomagnetically induced currents can trip offline in minutes. Astronauts and high-altitude crews face elevated radiation risk during peak disturbances. None of that has anything to do with interstellar intrigue. It has everything to do with plain space weather. That is the real irony in this moment. The interstellar object poses no threat. Its path arcs outward toward Jupiter's neighborhood and beyond, on a trajectory that neither intersects nor endangers us. The hazard, if there is one, comes from the familiar, not the foreign, from the star we see every day. 3IATLAS is a messenger in that sense. It reminds us that the sun has seasons and that peaks have consequences. Where does that leave the question people always want answered first? Is it natural? The disciplined answer is that nature has not run out of surprises yet. If 3IATLAS is natural, then we have likely encountered a class of interstellar debris with properties we have not cataloged. Thin, dry, nickel-skinned in places, optically odd, dynamically lively, and unusually responsive to solar plasma forcing. That would be a discovery in its own right. If it is not purely natural, if a subtle, repeatable, directed non-gravitational acceleration persists, while classical comet signals remain weak, then we are inching toward the first credible case of engineered behavior beyond Earth. That is not an announcement. It is a threshold. Either way, the right posture is the same. Measure carefully, publish cleanly, and let the residuals decide. As November unfolds, geometry still offers one last clean baseline before the signal-to-noise falls off. Watch 3 things in the technical releases. First, the fitted non-gravitational parameters, often labeled in orbit solutions as A-terms. If they remain non-zero across epochs and align with the timing of the brightening windows, the conservative space narrows. Second, any measurable change in rotation period after perihelion heating. A steady rotor where torque should have appeared is a clue that the system resists chaos. Third, the growth of skyplane separation versus the gravity-only track. If it rises faster than uncertainty shrinks, you are watching a real effect rather than a calibration ghost. Add to those the long-shot signature that would tip the scale all by itself. A narrowband emitter that repeats after dispersion correction across long baselines near protected bands. That would move this from dynamics to communication in a single step. There is also a cultural point that matters here. People are tired of being told to wait for data that never seems to arrive. The irritation is understandable. Calibration pipelines are messy. Budget events and maintenance windows are unromantic. A processing pause during a shutdown is bureaucratic, not conspiratorial. The proper remedy is not outrage. It is independent replication. And we have it. Multiple facilities, multiple teams, multiple pipelines have converged on the same behavior. You can be skeptical of any one group. It is harder and healthier to argue with the ensemble. Soon, 3IATLAS will climb outward toward the darkness between worlds, dimming into a point and then into a memory. We will not see it again, but the questions it sharpened will remain. What else slips through our solar system under our feet while our attention is pointed elsewhere? How much of the galaxy's detritus carries stories of formation and destruction that our instruments are only now good enough to hear? How many frameworks do we cling to because they have been good enough, when what we need is a willingness to add one more term to the model? Here is the most honest place to stand today. 3IATLAS has crossed the line from an odd rock with a curious light curve to an object with measured, repeatable non-gravitational acceleration and optical behavior that does not fit comfortably inside our cometary library. The brightness law near the sun was extreme. The polarization is anomalous. The composition hints are non-canonical. The rotation behaves more steadily than heating would advise. The geometry was inconvenient for easy pictures and perfect for careful work. None of this forces a dramatic conclusion. All of it forces better questions. If future data erase the extra term, we will say so plainly and gratefully. The universe owes us no mysteries. If the term persists and the conservative fixes spend the last of their credibility, a quieter sentence will replace the speculative ones. We will have measured, reluctantly and precisely, behavior that our natural catalogs do not comfortably own. The implications will not arrive in a headline. They will arrive as residuals that refuse to die, a rotation that refused to drift, spectra that refuse to say water comet, and a signal, optical, dynamical, perhaps radio, that refused to be coincidence. That is how reality enters the record. Until then, we will listen where the hydrogen line keeps its quiet guard, watch where the skyplane separation writes its slow arithmetic, and trace where the sun storms sketch their pale fingerprints across a coma that should have been simpler than this. Measure. Publish. Let the sky speak. 3IATLAS is still speaking, and the sun, loud now, restless, is answering. Now, restless is answering.